By the end of this video, you're going to be able to integrate what you see here like a ninja. Let's get started. The first thing I want you to notice, you have this constant 3 being multiplied by x cubed, and it's adding a little bit of complexity to the problem. The thing I'm going to recommend you start out with is using this property. Whenever you have the integral of a constant times a function, it's the same thing as bringing that constant outside of the integral. So in other words, you can focus your energy on first integrating f of x dx, and whatever answer you come up with, you can finish the problem by multiplying that by a. If we rewrite the original problem I gave you then, you simply get y equals the 3 times the integral of x cubed dx. You might be asking, how do I integrate x cubed? Well, remember with derivatives, this is what we normally would do. If I wanted to take the derivative of x cubed, I would get 3x squared dx. Because whenever you take the derivative of a polynomial that has a power of n, your result is going to bring a constant multiple of n times a new polynomial that has a power that's 1 less than what it used to be. So whenever you take the derivative of a polynomial, your power is going to decrease by 1. So if you take the derivative of x to the 4th, you get an answer that has a power of 3, etc. But remember, with an integral, which I gave you in the original problem here, we're going backwards. So instead of decreasing the power of x, we're actually increasing it by a power of 1. So looking at x cubed dx, we need to realize that whatever it is that we came from, that we took the derivative of, had to be something where the power of x is raised by 4 instead of 3. So let's do a little bit of trial and error. How would you take the derivative of x to the 4th? Pause the video and give it a try. Okay, if you took the derivative of x to the 4th, you would have come up with 4x cubed. But notice how with x cubed dx, the thing that we're integrating, we don't have this 4 right here. And that's a big hint. This is where you can use the power of reciprocals. Do you remember that whenever you have a fraction such as 3/2, if I multiply it by its reciprocal, which would be 2 over 3 here, in other words, flipping the fraction upside down, that's how you so-called cancel out the fraction and get a 1. So if taking the derivative of x to the 4th is 4x cubed, but the differential we started out with is x cubed dx, which has no term in front of it, how do we undo that 4? What should we multiply the x cubed dx term by to undo that fraction? Take a minute, pause the video, and see what you come up with. Okay, so if we don't want 4x cubed, because what we started out with only had x cubed, that tells us that we need to correct our guess by dividing the integral of x cubed dx by 4. So in other words, we're going to get that y equals 3 times 1/4 x to the 4th. And let's try it out. If I were to take the derivative of 1/4 x to the 4th, do we get x cubed? Let's give it a try. 1/4 x to the 4th. If that's our function, then taking its derivative would mean, using the product rule, that it's 1/4 times the derivative of x to the 4th. This is going to give you 1/4 times 4x cubed, and you'll see here that 4 and 1/4 cancel out. So we are good to go. But remember, in the original problem, we are now taking this result and multiplying everything by 3 because we took a 3 outside of the integral. So y will then be 3 times 1/4 x to the 4th. And remember, anytime you take the integral of something, you have to add this constant term at the end. We don't know what it is. Because whenever you take the derivative of some parent function to get to where we started, do you remember that taking the derivative of a constant is always 0? So we can't make an assumption that when we started out with y equals the integral of 3x cubed dx, that the original function was plus 0. It could have been something plus 7, something plus pi over 2. It doesn't matter. And so always remember that when you take the integral of something, your answer is actually going to be a family of functions. So you have to have this plus c term at the end. All right? So simplifying the final answer, we would get y equals 3 over 4 x to the fourth plus c. And to double check your answer, if you take the derivative of this, remember that the derivative of a sum of terms is like taking the derivative of the first term plus the derivative of the second. The derivative of the first term we already did above because we wanted to show that taking the derivative of 3/4 x to the fourth would give us the answer that we wanted. And then also, when you take the derivative of the plus c term, you will get 0. And in the original problem, you can look at it as adding 0 at the end. So I hope this video was helpful to you. Hit that subscribe button if you haven't already, and I'll catch you later.